All right then, welcome to the end of week review of the fall 2020 semester exam review. This video is intended for you to check back on if you need to re-review something later on after today, Friday, December 11th. All right, so tools of geometry, points, lines, and planes. Points are objects in space that have no set dimensions. We characterize these by capital letters. Lines, there are three types. We have lines, we have rays, and we have line segments. Each of these are defined by the existence of 2 points, named by either the 2 points that make up the line or by a lowercase letter. Planes, two-dimensional object that expands infinitely in both directions, named by 3 non-collinear points or by a capital letter in the corner. So this would be plane F, or it could be plane A, B, C. Now remember, there's exactly one line through any 2 points. There's exactly one plane through any 3 non-collinear points. Distance and midpoints. Distance formula. To find the distance between 2 points, we use the variation of the Pythagorean theorem. To find the distance between points -2, -1, and 2, 2, we'd simply plug and chug and get the, so we have the distance is equal to the square root of x sub 2, 2 minus a -2 squared plus 2 minus a -1 squared. Well, when you subtract a negative, that's the same as adding a positive. So we have 4 squared is 16, 3 squared is 9, 16 plus 9. This is the square root of 25, which is equal to plus or minus 5. But since we can't have negative distance, we are saying it's just 5. Midpoint formula. Midpoint formula of x sub 2 plus x sub 1 over 2 and y sub 2 plus y sub 1 over 2 gives us the point halfway between 2 points. In fact, we can actually rewrite this, make it a little nicer and more relatable to the fractional distance formula. X sub 2 plus x sub 1, comma, 1/2 y sub 2 plus y sub 1. And if we need to get some distance that's not 1/2, like 1/3, 2/3, 5/8, whatever, we can just replace that fraction. But for this problem, we want to find the midpoint between -2 and 1, -2, -1, and 2, 3. So we set up our problem as 1/2. Our x is being added together, so that's going to be -2 plus 2, comma, our 1/2 of our y's being added together, -1 plus 3. Well, 2 plus -2 is 0. Half of 0 is still going to be 0. -1 plus 3 is 2. Half of 2 is 1. Midpoint is 0, comma 1. Yeah, that's everything there. Yeah, that's everything there. All right. Next up, angles. So angles are a measurement of the space between 2 rays, or 2 lines, usually measured in degrees. Adjacent angles, 2 angles that share a same side. Vertical angles, angles formed by two intersecting lines on opposite ends of the vertex. Linear pairs, two lines that make up a same line that are adjacent to each other. Vertical pairs will always equal 180 degrees. Complementary angles, any two angles that when added together will give us 90 degrees. Supplementary angles, any two angles that when added together will give us 180 degrees. Bisected angles, these are angles cut in half. Angles in half. Congruent angles are angles that are equal. Find the missing variables. Well, number one looks like it's a setup of vertical angles, which allows us to write 3x minus 40 equals 2x minus 10. Combine our like terms, x equals 30. Number two, looks like we have a linear pair. So 6y minus 10 plus 6y plus 10 must equal 180. So 12y equals 180. So y is equal to 15. Number three, we have a right angle, a linear pair. And if this is a right angle, that means that this here must also be a right angle. If this is a right angle, then we can say that 4z minus 10 plus z is equal to 90. If that's the case, then 5z is equal to 100, or z is equal to 20. Number four, we want to find x and y. We're going to use our linear pairs and our vertical angles to do this. Vertical angles, because 98 must equal 7x. So x must equal, what was that, 14? And then 98 plus 5y minus 3 must equal 180 by definition of a linear pair. So 95 must do 95 plus 5y must equal 180. 5y must equal 85, which means y is equal to 15. Logic. So logic, we talked about different types of reasoning. Inductive reasoning, that deals with observations and patterns. Deductive reasoning, that deals with definitions and facts. And ideally, these are going to be true for whatever we are using them for. However, to prove them false, we need to come up with a counterexample, an example that proves a conjecture is false. So for example, if an angle is obtuse, then it measures 100 degrees. Well, we can find a counterexample there by naming any other obtuse angle, like 95 degrees is obtuse. It's the proof of an angle that's obtuse, that is not 100 degrees, therefore being a counterexample to the statement, if an angle is obtuse, then it measures 100 degrees. Our conjectures as a whole are based as if-then statements, with the whatever follows the if being our hypothesis, whatever follows the then is the conclusion. If P, then Q, being the standard form of our conditionals. That being said, there are variations, the converse, inverse, and contrapositive. Converses swap the position of our conclusion and hypothesis. So instead of if P then Q, we would have if Q then P. Inverses are the negative of the conditional. So instead of if P then Q, we would have if negative p, or if opposite of p, then opposite of q. Contrapositives. Contrapositives are going to be the opposites of the converse. So instead of if p then q, we'll have if opposite of q, then opposite of p. Properties review. So these 5 properties are fairly helpful when proving different things in geometry and mathematics as a whole, and I recommend reviewing all of them, especially midpoint and congruence. All right, parallel and perpendicular lines. When a transversal intersects 2 parallel lines, the following types of angles are formed. We have corresponding angles, which are going to be angles that are in the same positions. So 2 and 6, 3 and 4, 1 and 5, 4 and 8 are all corresponding angles, and all corresponding angles are going to be congruent to each other. Alternate interior. Well, alternate interior, alternate means on opposite sides of the transversal. Interior means inside the space between the 2 lines. Alternate interior, 3 and 5, 4 and 6 are all alternate interior, and these are all congruent to each other. Alternate exterior, we have our same thing, alternate, opposite sides of the transversal, but exterior existing outside of the 2 parallel lines. So 1 and 7, which would be congruent to each other, 2 and 8, which are congruent to each other. Consecutive interior. Consecutive means on the same side of transversal, interior inside the 2 lines, inside the 2 parallel lines. So in this case, 3 and 6 would be consecutive interiors, 4 and 5 would be consecutive interiors. Consecutive interiors can add up to equal 180, making them supplementary. Consecutive exterior. Well, consecutive exterior, consecutive, same side of the transversal. Exterior on the outsides of our parallel lines. So 2 and 7 are consecutive exterior, 1 and 8 are consecutive exterior. These also equal 180 when added up, making them supplementary. Slopes. We talked about 4 types of slopes in this unit. We talked about positive slopes, where m is equal to a positive number. We talked about negative slopes, where m is equal to a negative number. We talked about zero slopes, where m is equal to 0. This makes horizontal lines. And we talked about undefined slopes, where m is equal to some number divided by 0, which breaks mathematics. This creates vertical lines. And I'll show you proof for breaking mathematics next week in the little fun memesy folder for the exam week. Now we can find the slope with 2 ways. We can look at via formula, which you might recall from previous courses as rise over run, or you can do it graphically. But let's do rise over run real quick. I want to find the slope between -2, 0 and 1, 1. Plug in our values. So y sub 2, which is 1, minus 0 over x sub 2, which is 1, minus the -2. When we subtract negative, we're adding the positive, so therefore this equals 1 over 3, a positive slope. But we can also look at things graphically. rise over run. Well, it looks like this line is going down 2 units and over 3 units. So we have a negative 2/3 slope here. All right. We also talk about lines. Y equals mx plus b, the slope-intercept form, where m is our slope and b is our y-intercept. Such that if we wanted to have an equation with the slope of -2 and an intercept of 3, our equation would be y is equal to -2x plus 3. There's also the point slope form, what we use when we have a point and a known slope. Y minus the y coordinate of the point is equal to the slope times x minus the x coordinate of the point. Let's plug in what we know. M is a -2 going through a point of 3, -2. So y minus the y coordinate is equal to -2 times x minus 3. And once more, because we're subtracting negative, we're going to add a positive. Parallel lines. All parallel lines are going to have the same slope, whereas perpendicular lines will have the opposite reciprocal. That is to say that given the slopes of 2 perpendicular lines, m sub 1 times m sub 2 will always equal -1. So let's take this and work some problems. We'll write an equation of a line parallel to that of a line that has a slope of -2/3. So same slope, -3/2, and passes through -4, 5. So that's a point and a slope. We're going to use point slope form. So y is equal, y minus 5 is equal to -3/2 x plus 4. Because when we subtract a negative, we're adding a positive. A line perpendicular to a line with a slope of 5 that contains the point 1, -1. So again, point slope form, except this time we want the reciprocal of 5, the negative reciprocal of 5. We can work that out algebraically by saying that if m sub 1 times m sub 2 is equal to -1, and m sub 1 is 5, 5 times m sub 2 is equal to -1, then m sub 2, the new slope, is going to be -1/5. So y is equal, y minus a -1 is equal to -1/5 times x minus 1. And when we subtract a negative, we are adding a positive. Write the slope-intercept equation of 2x plus 3y equals 9. So we're going to solve this via reverse PEMDAS. So 2x plus 3y equals 9. We want to isolate that y. So we're going to move that 2x to the other side to give us 3y is equal to 9 minus 2x. Divide both sides by 3. Y equals 9 minus 2x over 3, which we can then simplify down to 9/3 minus 2/3x, which can be simplified and rewritten into -2/3 x plus 3. All right, triangles. Triangles can be classified by sides and by angles. By sides, scalenes, all sides are different. all sides different. Isosceles, two sides are equal, equilateral, all sides are equal. Classifying them by angles, acute triangles have all all angles are going to be less than 90. In a right triangle, we'll have one angle that's equal to 90. In obtuse triangles, we'll have one angle that is greater than 90. Triangle congruence. Corresponding parts of congruent triangles are by definition congruent. And we have 5 ways of doing congruency by parts. Our side, 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 so 3 congruent sides. Side, angle, side. 2 sides plus their included angle are congruent. Angle, side, angle, 2 angles plus included side are congruent. Angle, angle, side, 2 angles plus a non-included side are congruent. Then hypotenuse, leg, the hypotenuse and a leg are congruent. Now, hypotenuse leg will only show up in right triangles, but right triangles can be congruent by side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg. Now, which ones don't work? Well, there are 2 of them that don't actually work for us. Angle, angle, angle does not work. Neither does side, side, angle. The triangle sum theorem. The triangle sum theorem states that all triangles have degrees that equal 180 degrees, always. The exterior angle theorem, that's actually made up most of the problems in this unit. Given this setup, A, B, C, D, 3 and 4, 1 and 2, that angle 1 plus angle 2 must equal angle 4. The reason why that's true has to do with our triangle angle sum theorem as well as our linear pair idea. Because in a triangle with angles 1, 2, 3, and 4, our triangle angle sum theorem says that angle 1 plus angle 2 plus angle 3 must equal 180 degrees. And our linear pairs definition says that angle 3 plus angle 4 must equal 180 degrees. Well, since they both equal 180 degrees, we can set them equal to each other. Angle 1 plus angle 2 plus angle 3 is equal to angle 3 plus angle 4. And look, we've got angle 3 on both sides. So if I subtract angle 3 from both sides, I end up with my exterior angle theorem. Angle 1 plus angle 2 must equal angle 4. Practice problems. Find the measure of each numbered angle. Well, Here, number 1, we have the setup for an exterior angle theorem, such that angle 1 is equal to 50 plus 65, or 115. Whereas in problem number 2, we have an interior angle theorem, such that angle 1 plus 62 plus 90 must equal 180, which means that angle 1 must equal 28. 3 through 7, we have a puzzle to unlock. So, angle 1, exterior angle theorem. (60 plus 80 equals angle 1, so angle 1 must equal 140. Angle 1 and angle 2, well, angle 1 is 140. Linear pair means that angle 2 must be 40 degrees, because all linear pairs must add up to 180. Angle 3, we have an exterior angle situation again. We have a 40, we have an unknown angle 3, and we have a 105. So 40 plus angle 3 must equal 105, which means that angle 3 must be 65. Angle 4, well, angle 4 and 105 are a linear pair. So by definition, angle 4 must be supplementary to 105, which means angle 4 must be 75. And if 75 is angle 4, then 75 plus 40 equals angle 5. Angle 5 must be 115. All right, so number 8, we want to identify which postulate we can use to prove triangles below are congruent. If not, we're not going to prove. So, first things first, in A, we're going to identify what we have there. It looks like we have a side-side angle, but side-side angle is not one of the ones that we have. So we would say this is going to be not possible. In B, looks like we have a side angle side. So we can say that, we can say that triangle MKJ is congruent to triangle MKL. In C, looks like we have an angle side, which is one of our possibilities. So we can say that triangle ABC is congruent to triangle ADC. (9 through 11), we want to identify and solve for x. So number 9, we have an isosceles triangle. Because our base angles are congruent, that therefore means that these two must be congruent. If those two sides are congruent, we can set up an equality equation as 2x plus 6 is equal to 3x minus 6. Combine our like terms, and we'll end up with x equals 12. Number 10, once more, we have an isosceles triangle. And because this is congruent to that, that means that this angle must be congruent to that angle. So angle Q must be congruent to angle R, which means that angle R is equal to 2x. If angle R is 2x, that means that 40 plus 2x plus 2x must equal 180 because of our triangle angle sum theorem, which when we combine like terms, 4x equals 140, or x equals 35. Last problem. We have what appears to be an isosceles triangle. this side is congruent to that side. We have this weird thing, 4x minus 4 down here. It seems like this might be a broken problem, but it's not. So in fact, we would start this problem by looking at the angles. So 60 is there, and these two angles must be the same. So we can say that angle Z must equal angle Y, and that angle X plus angle Y plus angle Z must equal 180. So 60 plus angle Y plus, well, another angle Y, because Y equals Z, equals 180. So 2 angle Y must equal 120. So angle Y must equal 60. If angle Y equals 60, then angle Z must equal 60, which means that this isn't an isosceles triangle. It's actually an equilateral triangle. So now we can prove that these two, that 3x plus 8 is equal to 4x minus 4, which when we combine like terms, we'll end up with x is equal to 12. All right. That brings us to today, to our special segments. So, perpendicular bisectors have a point of concurrency known as the circumcenter. Properties of the perpendicular bisectors, well, they make 90-degree angles with the side, and they go through the midpoints of the side. So they create congruent parts. Also, that the circumcenter, CC, is equidistant, to vertices. So in a triangle, the distance to that vertex, and that vertex are all congruent. Angle bisectors. Angle bisectors have a point of concurrency known as the incenter. The incenter, in turn, is equidistant to sides at a 90-degree angle. Whereas angle bisectors will cut angles in half. So, hypothetical triangle, that's our incenter. Distance to all sides, make right angles, and they're all equal to each other. Medians. Medians have the centroid for concurrency. Medians go from vertices to midpoints. So they also create congruent segments. And they also have the 4 equations that are oh so important. That short segments are equal to half of long segments. Short segments are equal to 1/3 of the whole median. Long segments are equal to twice the short segments. And long segments are equal to 2/3 of the whole median. So in a hypothetical triangle, say A and B point, let's call that D. We would say that segment AB is our whole segment. AD is the long segment because it runs from the vertex to the centroid. And that segment, DB, is our short segment because it runs from the centroid to the opposite side. Lastly, we have the altitudes. Altitudes meet in what is known as the orthocenter. Altitudes also make 90-degree angles, but they might not be inside a triangle. What I mean by that is, depending on what kind of triangle we have, the orthocenter might be in different locations. In an acute triangle, the orthocenter is inside. So inside for acute. In a right triangle, the orthocenter is actually going to be on the triangle at the right angle. And in an obtuse triangle, the orthocenter is going to be outside the triangle. Obtuse. All right. Last little bit here before we work the final set of problems. The largest angle in a triangle is going to be opposite to the longest side. Always. While the smallest angle is opposite the smallest side. Always. The sum of the lengths of any two sides of a triangle will always be greater than the length of the third side. This essentially sets up our triangle inequalities. So let's take a look at the ones. In questions 1 and 2, we want to identify the largest possible segment, but we don't have any segments to measure. Instead, we have our angles. The largest angle will be opposite the longest side. So the longest side here is going to be opposite angle Q, which makes side PS our longest segment. Our shortest segment, well, that's going to be opposite that 28 there. Opposite the 28, we have PQ, making that the shortest segment. Number 3, which of the following sets of numbers can be the lengths of the sides of a triangle? Well, the sum of any two sides must be greater than the third side. So let's check real quick. Let's take the smallest sides, add them together, see if they're bigger than the third side. 9 plus 2 is 11. 11 is not bigger than 14. 11 plus 12 is equal to 23. 23 is not bigger than 23. 5 plus 3 equals 8. 8 is not bigger than 9. 5 plus 8 equals 13. 13 is bigger than 12. Point P is the circumcenter. Circumcenter means that we are dealing with perpendicular bisectors. Lists any segments that are congruent to each segment given. So I'm not even going to look at the three things here. First, I'm going to mark up my figure because I'm dealing with perpendicular bisectors. So I know that at each of these 90-degree angles, I essentially have segments that are going to be congruent on either side. So AS is congruent to SC, TC is congruent to BT, BR is congruent to RA, and because circumcenters have incenters, because circumcenters are the perpendicular concurrency point, the circumcenter is going to be equidistant to each vertex. So PA is congruent to PC and congruent to PB. So now, having marked up my figure, I can go look at the problems. BT. Well, BT has the same congruency marks as segment TC. AP has the same congruency marks as PC, and PB. AS has the same congruency marks as SC. All right, triangle CDE, we have centroids. Centroids are medians. And medians have those four special equations, such that let's go with white, such that the short side, the short segment, is equal to half of the long segment. The short segment is equal to 1/3 of the whole segment. The long segment is equal to twice the short segment. And the long segment is equal to 2/3 of the whole segment. All right, equation set up. Let's work our problems. UC is 12. So UC, measurement of 12. EM is 36. UJ is 5. So from this, we're going to work the rest of our problems. First up, KU. KU looks like a short segment. We have the long segment. So we're going to use our relationship between the short, which is 1/2 the long, to identify that KU has a measurement of 6. CK, well, CK is our full median, which the full median is, and the short median is 1/3 the whole median, or we can use our segment addition postulate, 12 plus 6, to give us 18. EU looks like a long segment. We have the whole median. The long segment is 2/3 the whole segment, which means that 2/3 of 36 gives us 24. MU is down here, the short segment. The short segment is half the long segment. The long segment is 24. UM or MU must be 12. JD, well, JD looks like the whole segment. We know the short segment. The relationship between the short segment and the whole segment is that the short segment is 1/3 the whole. 5 is 1/3 of 15. And finally, UD. UD is the long segment. We know the short segment. The long segment is twice the short segment. So 2 times 5 gives us 10. And that, folks, is the completion of this week's review in a truncated format. As always, if you have additional questions, please send me an email and let me know. We'll also have one additional review before each period's respective test. Take care. Good luck.